now. We'll start now the recording. So I will start with a big thanks, Karin and Hans, for taking the time and sharing your knowledge with our users. This is the 47th event of Romanian Oracle user group. We call them tech sessions, and they are usually done in the evening. And this is one of them. And this year, Romanian Oracle user group is celebrating 10 years of activity. We started in 2012. So we are very glad that we managed to resist 10 years, and we'll hope to go further. A little bit on this event. So the event is on spatial technologies from Oracle. Probably everyone received the presentation or read it on our website. So model, visualize, and analysis of relation using graphs in Oracle database. Karin is product manager from Oracle on spatial and graph technologies, senior principal product manager. So as a very nice, let's say, introduction, I realized when she sent the bio that she graduated the Polytechnical University from Bucharest. So let's say she's a new alumni of a Romanian university, and this makes us very, let's say, happy and proud in the same time. And yeah, so this is let's say the introduction. Thank you again, and I will close my microphone and stop my video and let you go. Thank you.
Okay, Ciprian, thanks a lot for the brief introduction. Let me do some housekeeping here and share my presentation first, or at least start the presentation. So, just a second. Okay, so can you see my slide deck?
Yep, that works.
Yes.
Slide deck. Okay, perfect. So thanks a lot, Ciprian, for having us presenting one of our two favorite topics here in this tech session for the Romanian user group. Maybe we can extend the introduction a little bit. So maybe Hans, are you going to introduce yourself as well?
Yeah, I mean, there's not too much to say about me. I'm working on the same team as Karin. I am a product manager with the Spatial and Graph product management team. So I'm part of the database development organization at Oracle. I've been with Oracle for many years. I started with the spatial technologies, turned that into a sustainable business for Oracle Germany back in the 1990s, and then moved on to a couple of different roles inside of Oracle. And now in the product management, I've been doing product management for a little over 10 years now. And there I've been focusing not only on the spatial technologies, but also on the graph features we have in the database, which are going to be our topic today. I'm just like Karin, I'm based out of Germany. While Karin is in Berlin, I'm in Hamburg. So if ever you come to the northern part of Germany, not only to Nuremberg, then Hamburg is certainly a place I can recommend. And other than that, most of my folks are based on the US East Coast, but we have colleagues on the West Coast, as well as we have one product manager in Asia Pacific based out of Japan. You may have come across him if you are following us on social media. His name is Ryota Yamanaka. Right, Karin, with that, I think back to you.
Yeah, so as Ciprian mentioned already, so I've studied, actually, I'm a computer scientist and I've studied at the Polytechnica. So, but I felt free to leave Romania before I graduated, which I did in Germany then. So after 4 years of living and studying in Bucharest, I went back to Germany, or that time to Eastern Germany, and finished my studies there, but got a child in between, so this was my priority by then. But I still have lots of connections to my former colleagues, and every couple of years we meet in Bucharest or somewhere in the surroundings. So I'm still, that's why I'm especially happy to present for the Romanian user group. Okay, so much about me and about Hans. Maybe we go ahead with, or just one more thing to say is, so please feel free to ask your questions during the session. We are not that many people in the session, so we will have time to either directly answer on those, or use a chat to put your questions there, and Hans is going to answer your questions via chat during I do the presentation. Part of the presentation is also a demo in an Oracle cloud environment. We have not prepared something you do yourself by or manually during the session, so stay lazy, just follow the presentation and the live demo, and feel free to answer your question every time they pop up. Okay, good. So now, before we come to specifically look in depth at what we call graph technologies, let me briefly put things we are going to talk about today in more context. So graph technologies are a part of the multimodal capabilities of the Oracle database. So most of you probably know that you can use the Oracle database not only for storing relational table, you can use them also to store document-centric data like JSON data or XML documents. You can use it to store and manage your spatial data, or do spatial analytics as part of the Oracle database, or you can even use the Oracle database for machine learning type of requirements. So we are not restricted to the relational world anymore, which has been the case for a very long time already. So since I started working with Oracle in 2007, all these things, most of these things we already supported by then. What is new since then is the capability to work with graphs and to work with JSON documents, or also to support blockchains and IT. All these capabilities are especially focused on what is needed to develop data-centric applications, and that's why we have these features included in all editions of the Oracle database. So there is no longer a separation of the database and database options providing part of the capabilities. You have all these features that are listed here on this slide as part of every Oracle database edition and every Oracle database cloud service. So you don't need any separate licenses to work with those features. The graph technologies are an integral part of that, and what they specifically offer is a different view on your existing data. This means they enable you to generate value from data in other ways. So I will try to make it more clearly what it means in the next few minutes, and looking at the next slides. So this is what we are focusing on graph analysis as part of the Oracle database. So maybe I should emphasize two more things before I go further. We do support, as part of our, or we do support two different graph models in the Oracle database. One has been there for a longer time already, which is called RDF graph. Probably it's better known as RDF knowledge graph or semantic technology support. This has been part of the Oracle database since version 10.2. And this is a feature especially used in the linked open data area, or for semantic web technology, or as part of semantic web technologies. And the second part of, or the second graph data model we are supporting with the Oracle database is what we call property graph. Property graph is a very generic type of graph by using a model that is based on nodes and edges. So nodes representing entities or types of information, and the edges representing the relationships between those nodes. We, as part of the property graph support, we have a graph query language. We are going to look at how this looks like and how you put your queries, or and what kind of results those queries deliver during the presentation. And I also have some samples included in the slides. We are also looking at the support for graph algorithms and graph visualization. And we are also going to present a few use cases. Hans is going to tell some more details about recent customer projects we have been doing, and some specifics about those as far as we are allowed to talk about them. So what we are going to focus on today is on this property graph feature support. So as I said, a very generic a graph with links, with nodes and edges, and nodes and edges can have a set of properties assigned each. So we can have here, we do have here a different type of modeling data, kind of schema-less approach, which is extendable in terms of new nodes, new relationships, hence edges, and also in terms of attributes assigned to nodes and edges. Together with the Oracle database and our support for property graph, we do deliver additional tools. We are going to talk about those tools more in details later. These are part, or these can be used together with the Oracle database, and also do not require any additional licenses. So we have something called a graph server and graph client, and a graph visualization application that can be downloaded from Oracle Technology Network or from edelivery.oracle.com. And we also have something called Autonomous Database Graph Studio, which is actually an embedded tool for modeling graphs, querying graphs, and visualizing graphs as part of the autonomous database. So why would you use a graph database? As I said before, we want to have a new view on existing data or modeling data in a new way. And graphs are especially useful when it comes to discover and understand relationships and the importance of it. And for example, when we have a relational data model, like you can see it here, we have a customer table, an accounts table, and a transaction table. And we want to use this to represent or to have a graph representation of this relational model. Then it is especially interesting to figure out how we can use this relational model and transform it into a graph in order to raise new questions about this type of data. For example, one of the questions would be, is there a money flow between two people, let's say two of the customers, Bob and Charlie? Or is there a specific cluster, or are there any clusters of transactions, which means is there a specific pattern of frequent transactions between certain accounts or customers? And on the other hand, are there any accounts that have no connection to that are not included in any of those clusters or outside of the clusters? And to answer these kind of questions in a relational world, you would typically need to join the tables, to have multiple joins of the tables, to do self-joins, have recursive queries, which can take a long time, consume cost a lot, and probably are not very performant to deliver the results. Or you would probably need sophisticated PSQL code to run the queries or to do some specific analysis. So, I'm sorry, too fast. So here, what you can see is a graph representation of the same relational model I've shown you before. So we have the accounts or the customers translated into nodes in a graph, pointing to accounts. Here with A1 to. Pardon me? Okay. So pointing to accounts or having a relationship with accounts, then we have a flow of money going between the accounts, and the accounts belong to certain customers. So when answering right now, whether we have a money flow going from Bob to Charlie, then you can already, by having this visual translation of the money flow, we can already answer the question that we have this money flow between Bob and Charlie via the accounts A1, A3, A5, A4. So this is very easy to discover by just following the path of transactions from specific customers and their accounts. When what you can do, or what you can also do, looking at the graph and having the data model at this graph, is to query the graph in certain ways. So you can use that graph model to detect cycles in the flow of transactions, to figure out whether there is probably some fraudulent money transfer, so money that goes from one account over certain other, or from one account over certain other accounts, and coming back into the same account from the beginning. Those kind of things you can query using a graph model very easily. You can do path findings using the graph model, or do very fast, you can very fast traverse the graph, since you have the relationships between the different nodes explicitly stored, and you can follow on them. When it comes to identifies clusters of transactions, so the second type of question I mentioned before, you can use algorithms from the graph theory to detect a specific community. So you can see here we have 4 clusters of communities, so accounts that belong to each other by the number of transactions going between them, and those that have only spare connections between the certain accounts. So you have this type of analysis to find the communities within your graph. You also have different graph algorithms to do ranking of nodes in the graph to find central nodes in the graph, or to use those for path findings and connectivities, or to predict links in a graph, or to do similarity searches within the graph. So there's a whole lot of graph algorithms that are pre-built and can be used, and I'm going to show those in a couple of slides as well. We've put together an ebook that talks about typical use cases for graph and for graph databases and graph analytics. You can download it and have a look. Maybe there are use cases that match with requirements you are having, or you will have in the future, or those can give you some ideas how to use graph capabilities for your own business. Okay, with that, maybe Hans is going to give you some more ideas based on projects we have been doing with our customers in the recent futures, in recent past. I'm sorry. So Hans, would you like to take over?
Yep. I think you can keep on sharing, and I'll try to say a few words about the presentations. Right. Yes, I'll let you know. But maybe it's a good time to take a breath and see if there are any questions. Does anybody have any questions about the fundamentals of graph technologies? I hope it's become clear that graph databases are special in that they store the relationship explicitly, right? Unlike in the relational world where you do a join only at runtime, and that they are a class of database, just like document store or key value pair database or the like, right? With their dedicated storage structures. Anybody any questions at this point? If that's not the case, let me give you a couple of ideas of what customers are actually using these technologies for. We're seeing many customers, particularly in the financial services area, for different reasons, and I'll show you some use cases in just a moment. Because the technology is so widely applicable, so generic, we're seeing customers in all kinds of industries using these technologies. Financial services are particular because they have a lot of regulatory pressure, for example, but also they want to use graph technologies for targeted marketing and the like. We have manufacturing customers. In that case, that's primarily to do with parts hierarchies and bill of material data and so forth. Public sector is important, and there are various use cases, horizontal use cases, which I'll talk about in just a minute. One example is a company which you may or may not have come across if you are working with e-wallets and online payments and so on. It's a company called PaySafe. PaySafe are headquartered in Canada, but most of their development team is actually based out of, or the graph analytics team is based out of Bulgaria. And no, I didn't meet them at the Romanian Oracle user group, but I met them at the Bulgarian Oracle user group for the first time before we started this project. What they are using our technologies for is they represent all of their e-wallets, and it's actually what you see here in that little screenshot. They represent their e-wallets as vertices in the graph, and every financial transfer, like what Karin was just explaining with Bob and Charlie, every financial transfer is an edge. And in their huge amounts of transaction data, they're looking for undesired patterns, fraudulent activities, and so on. Because obviously, these kinds of online transaction services, online financial services, are particularly prone to fraud, and therefore they need to take great care that they don't have too high a rate of fraudulent transactions. Right, so that's one. Maybe you can go on to the next. The next example we have is one of our larger manufacturing customers. You probably know Mazda as a automotive company, right? They, like any car manufacturer, they have a variety of models and so many variants on their models that keeping track of all the parts that are required to build a specific model is actually an interesting challenge. And like all of the manufacturing customers, they have two challenges. One is to figure out if they have enough of each part to build a certain variant of a given model, or vice versa. You start with a part, you know, you say like what you have at the moment in the car industry, right? They have problems with silicon chips, so they need to know which model, which variant of which model depends on a specific type of silicon chip, and that is kind of the same question, but sort of bottom to top rather than top to bottom. Right? This is what customers typically use graph technologies for, because these bill of materials, these hierarchies of parts, are so complex and intertwined that it is not trivial to work with these in a relational model, particularly if you take versioning into account and look at also the evolution of the different models over time and so forth. So that's where graphs can contribute big time. And then if we move on to the next example, that's a kind of similar use case. If you click, okay, that's a similar use case in that it's also a manufacturing customer, a company from Germany that is manufacturing and selling heating and cooling systems, a company called Fiesmann, and they use graph technologies for a similar purpose on their B2B e-commerce portal, where they have a catalog of parts and part hierarchies, and that's the tricky thing. They have part hierarchies, and then for a given model to figure out, okay, what is the replacement part, what is a maintenance part for this given model in the given variant, maybe from a given time frame and so forth. That's where they traverse down the hierarchy using graph technologies, because it is a very natural way for them to represent their bill of material data and to figure out which part belongs to which variant of which model and so forth. Right, next is more of a public sector example. That's something which we see here in the EU occasionally, or actually more than most companies, more than most countries admit. We have the challenge of EU VAT fraud, where, I don't know if you know how this works, but if you import goods, say you import a container full of sports shoes from China, then if you import that into the European Union, then there's no tax, because it's just a regular import. And then when you resell it with VAT, and you have to pay the VAT to the tax authorities, obviously. And then it's being resold and resold and resold. And then if you then resell it outside of the European Union, then you get a VAT refund. Now, if the first company in that chain is a fake company with just some straw man who has no financial means at all anyway, as a director, and that importing company doesn't pay the VAT, and there's no way of getting hold of anyone in that company who can pay the VAT after the fact, then you're draining money from the system. And to identify this, this is what the tax authorities, the tax agencies are after. And here you are typically looking at circular money flows, or in the opposite direction, circular invoices in these kinds of systems. Usually it's not quite as straightforward as in this little graph here, because it's more tree-like, selling and reselling the different goods and combinations of goods. But that's the overall idea. And for that, again, because you're looking for specific patterns, you're looking for circular payments and the like, this is where graph databases are just very good. Okay, next, another public sector example from police environment. They have police forces. They typically have two things. They have either the case management, where you're looking at which person, or let's say which suspect who owns a car which has been involved in a car accident, which was related to an insurance claim, which was associated with a victim, and so on. You have this chain of relationships where you want to figure out, okay, is there a connection maybe between the suspect and the victim or something, right, over several hops. That's one thing. Here, what you can see on the on that little screenshot is a different use case. That's co-traveler analysis, where we have a customer in Southern Europe using our technologies to identify people who are traveling on the same aircraft or on the same ship with a known criminal. Now, obviously, that can happen to anyone. It can happen to you. It can happen to me. But if that happens more than once, then this is suspicious, because it could be that there's somebody who's involved in human trafficking or something. So this is what they are looking at, and it's not trivial to figure out who's been traveling together with whom in a relational world, and you can just nicely represent that as a graph and use graph algorithms such as betweenness centrality to find out which vertices or which people are particularly prominent, are particularly important, which are sticking out from the rest. As Karin was saying, it gives you a different perspective on the same set of data. Right, and if you move to the final use, sorry, I think I've got two more. One is this is one of the horizontal use cases, which may be applicable to you and me and anybody, which is related to GDPR. You can use graphs very nicely to figure out which user of a given application has access to which kind of information. So, for example, this is an example which our partner Datalysis from Switzerland has built on the basis of the Oracle BI metadata repository. What they've been trying to find out is which user who has access to which dashboard, which in turn sits on top of which table, which view, which sits on which table, which includes which column that has personally identifiable information for your credit card information or something, right? So over several steps, over several hops in the graph, you want to figure out which which user, maybe also through which role or which privilege, has access to personally identifiable information. Or vice versa, if you have a given column in a table, you want to figure out, okay, which users as part of which application and which role and which privilege have access to this information. That's kind of the opposite thing. If you do that with a relational model, obviously it would be like what Karin was explaining in the beginning with the financial services example. You'll end up with many joins and self-joins and so forth. You can do it, but it may be somewhat cumbersome, and you typically end up with fairly complex SQL statements which are kind of hard to understand and not easy to maintain either, especially if you have one recursive part in it, which just makes it a little more complicated, at least for me. I mean, that's my personal challenge with that. Okay, so this is a typical GDPR or generally security related scenario, and the last example I want to share with you is more related to application modernization. Not sure if you've come across an Oracle partner who's been around for a long time called PITS. PITS are particularly good at application modernization, and they're using graph technologies to analyze software artifacts and how they are connected, right? So if you take an Oracle Forms application, for example, and you look at all the different components in that Forms application, the PL/SQL code fragments, the variables, the different forms, the actions, so the events which are executed when you click on a button or whatever, right? If you take all of these artifacts and the relationships between them, then you can use graph technologies very nicely to figure out which part of the application is more closely interconnected than it is connected with the rest of the environment. Or you can use it for dependency analysis, right? You can figure out, okay, if I have this column, sorry, I have this table. What if I want to modify a column, right? Turn a varchar 250 into a varchar 200. What does that influence? Which objects are sitting on top of it, and so forth. And Karin will have an example which takes a look at that in practice a little later. Right. So I hope I've given you a couple of ideas of what kind of use cases our customers are addressing with graph technologies. Anybody, any questions about this? If that's not the case, then I'll move on to one more example, which I wanted to talk about in a little more depth. Again, a financial services example. You may have heard of CaixaBank as a Spanish retail bank. They have a big data lake, which they've set up a couple of years back, 1.5 petabytes worth of data. And as part of that data lake, they, among other things, also store all accounts and all transactions between the accounts. And they use that together with our graph analytics for the purpose of real-time transaction monitoring. So they create a big graph, which has all of the accounts and all of the links between the accounts which come from previous transfers between them, so that they know that money has been flowing from account A to account B at some stage, so that they can also determine if indirectly money has been flowing between certain accounts, like in the example of Bob and Charlie, which Karin was talking about. What they do is, for every incoming transaction, they look at whether the target account is indirectly connected to someone who's been involved in either fraudulent activity, or who is maybe a Russian oligarch, or on some embargo list, or is associated with a tax haven. If somebody's got an account in the British Virgin Islands or something, that's what they look at. And if that is the case, then they stop the transaction. Now, as they do this for every transaction, we're talking up to, I think, 300,000 transactions per day, which means they had a strict requirement of having only 30 milliseconds response time for every check, and that check is a 4-hop query. So they look at not only is the target account a fraudulent account, or has that target account an association, a direct link to a fraudulent account, but they use that for queries up to 4 hops. So that can be quite a few hops. And as I said, 30 milliseconds response time was what was required, and we were the only ones who could deliver that. In the meantime, they've added a number of additional use cases on top. For example, one on customer 360 analysis. And if you move to the next slide, I wanted to use that as an opportunity to show you what the workflow looks like, right? Because what they are doing is, besides the transactions and accounts, they also store all kinds of information about their customers. What you can see on the right-hand side is actually the meta model of that graph, right? They have 42 million vertices of type client. They have about as many of type telephone. They have 35 million vertices of type address. They have all the credit cards. They have all the accounts. And they also look at which credit card's been using for which kind of transfer and so on. And from this pattern, they are trying to figure out whether there are any interactions between the different clients. So if you click, Karin, then we'll have a build here. Here we are, correct. So they look at which client with which credit card has been shopping in the same place at the same time as somebody else, for example, which customers are transferring money between them and have some, like a birthday or something in the description of the purpose, and so forth. And from that information, they are trying to figure out information about clients they don't know so well, if they are connected to clients they know well, right? If there's a well-known customer and he's got a son, and that son opens a new account and is a student, he obviously will have a very bad risk profile. But over time, if it's becoming clear that there are transactions with the customer they know well, because maybe for his birthday, the mother sends money to the son and things like that, or they're going to the restaurant together and the like, then it becomes clear that, oh, there must be a relationship with this young person we don't know well and the two people we do know well. So it has an impact on their risk writing, and they use it for targeted marketing. Now, in order to do this, and that was the main point I wanted to briefly touch on, is they extract the structured information from the data lake into a graph. Out of that huge graph with all customers, they only look at the ones here which are individual customers. So they don't have all these corporate clients and stuff, which means they extract a subgraph out of the big graph. And then they move this part of the data into the graph data structures, perform graph algorithms. In that case, they are trying to figure out the community around each client, and from that community they're trying to figure out, okay, what are the typical characteristics of this community, right? Is this a family? Is this a group of friends? Where do they interact? How do they interact? And so forth. So they do the interactive analysis, and then based on the results, they push the results out into their marketing systems for campaigns or the like. Right, that's the overall idea. And with that, I'd like to hand back to Karin to show us in more practice what this looks like.
Okay, thanks a lot, Hans. Okay, maybe before I do the hands-on or the practice part, just let me briefly summarize the information we've already touched on and put it into a more structured complete on this kind of information. So when I talked about the Oracle database and additional tooling we have available to use the graph capabilities fully, I mentioned that we have something called graph server and client tools, and this is something we offer for download on either Oracle.com, Oracle Technology Network, or on eDelivery. And so you can download it there and install it on your own environment. We also have this available as a pre-built image in the Oracle Cloud. This can be retrieved from the Oracle Marketplace and installed it using the Terraform approach, where you get all the necessary cloud services set up in order to use the Oracle Graph Server and client fully. It also spins up the required network resources, virtual machines, so you don't have to take care of anything yourself. And if you don't need it any longer, you just destroy everything that has been made available before. So the graph server especially is in a memory engine to run the graph analytics part and also to do the querying using property graph query language. As for the graph algorithms, we have about 60 plus something built in graph algorithms. This number is actually evolving with every new version, but there's also an interface where you can develop your own graph algorithms or do variations of existing graph algorithms. One of the customer examples Hans mentioned, our partner PITS, they have actually taken the Louvain algorithm, that is a pre-built algorithm, and have adapted this to their own needs. So you can actually do this also on your own. So this is the graph server, and a memory engine that works highly in parallel, that takes the graph or that retrieves the graph from the database, constructs in the memory structure for the graph that is optimized to run all the graph algorithms. We also have client tools like a JShell client or a Python client, or having an integration with notebooks to run the graph algorithms and the querying in the client. We also provide a plugin for SQLCL. I don't know whether you know about SQLCL, some fancy new version, I would say, for SQL Plus. It's very well known in the Oracle user community. And yeah, I briefly can, oh, no, I haven't prepared for today, but I can mention it later when doing the demo. And we have the built-in graph visualization tool that is an application, web application you can download also from Oracle Technology Network or the Graph Studio built-in visualization of the autonomous database I mentioned before. So whether you are going to work on your own environment, spinning up all the requirements or all the whole environment you need, or using Oracle Cloud Services, you are free to use the complete functionality on your own. Graph Studio actually is the easiest way to use Graph at the moment, since you don't need to install anything. The only thing you're going you need to do is setting up a graph user with the necessary privileges to run Graph Studio and to do all the graph analysis and querying in the Graph Studio environment. But that's actually everything you need to do on your own. And Graph Studio is a self-service graph database embedded in the Oracle Autonomous Database on the Oracle Cloud, and provides you with a set of features that enable you to do the whole graph analytics workflow via this user interface. I'm going to show this also later on. And of course, it makes use of all the capabilities that come along with the autonomous database in terms of self-driving, self-securing, or self-repairing. So you don't need to take care for anything that is related to the database in terms of database administration, or so the usual things you need to do as an Oracle DBA. So what I'm going to show as a demo scenario, which is also described in as a live labs workshop, I'm going to share the link to that live labs workshop also. What we are going to do there is taking a relational model of a similar use case we've seen before. So we are going to look at bank accounts and transaction between those bank accounts that are stored in two tables. Then we are going to take these data and translate these into a graph model. And then we are going to do some analysis on that graph model in order to find out whether there are any circular payments or whether there are any important accounts, meaning that there are lots of incoming transactions. And this is something we specifically use graph algorithms for. So the demo workflow when working with Graph Studio is you create the graph model based on your existing relational data. You populate the data structures, meaning that you read the data into the in memory, and then perform the queries, execute your algorithms, and visualize the results. So when creating a relational or a graph model from relational data, I have just mentioned that we have this Oracle Live Labs workshop that actually guides you step by step in what you need to do and how you do the certain steps in that graph analytics workflow. And this is available on developer.oracle.com on Live Labs. And I'm also going to share the direct link, which I'm going to show right now.
I have already put the direct link into the chat,
okay,
so you can
I'm going to
click on that straight away.
Because I have plenty of cases, so maybe I'm going to directly go into the demo case. So this is a Live Lab workshop with a direct link. So the workshop ID is 770 exactly. Then you can run it on your own Oracle tenant. You can also use a free tier tenant for this. And I'm going to skip some of the labs here. So provision an autonomous database instance. You probably have done this on your own already, but if you haven't, you can do it here. Then we need to create that graph user. Maybe I just briefly show what that means. So you actually use the database actions in the autonomous database to create the user, and then assign these privileges required for that user, which is actually something you can do here, creating user, then assigning the privileges. And since this is a graphical user interface, you can use that item here to enable the user to be able to use graph features. So that's actually everything you need to do here. But of course, since it's a plugger database, you need to assign also a quota here, and then just to make sure that this user can create own data as well. Okay, so that's everything what's needed to use Graph for autonomous database. Then you can also use this workshop to load sample data, which is actually are two tables that are created, and it's also easily done using the database actions. As part of the database actions, you have this data load feature. Can you see that? Maybe I'm going to, it's not going to be.
Yeah, that's good enough.
Okay, so you have the data tools here, and you can load data from your local file system or data stored in the object storage, and then create out of the box the necessary tables containing the data then. And this is something I've already done here. So exactly. So my session retired, but I'm still here in the database actions. So you should see it now. I have the bank accounts table and the transaction table, and here you see the data in that table. And what you can also see here already on the left side where the navigation is, there are a few tables created as part of the modeling phase. So we take the relational model, translate it into a graph model, and what we are doing there is actually store metadata about that graph model. We don't duplicate any data. It's a relational, it's a metadata set that we put on top of that, which is stored in these tables that are named after the graph that is created in the Graph Studio tool. So please don't remove those kind of tables since you probably don't know where they come from. These are tables created from Graph Studio for that specific graph. And you can see here plenty of other graphs already created for different types of use cases. Okay, so maybe I'm going to sign in back to my cloud environment. So we have the autonomous database here. This is my autonomous database having that specific user called graph user. And if you open that database and look on the tools, there you see Graph Studio once, not once, there you see Graph Studio as feature of the autonomous database. You can use it together with autonomous data warehouse instances and also autonomous transactional processing instances. You can't use it with a JSON autonomous database or an Apex autonomous database. So it's restricted to the two types of workloads available for the autonomous database. And since I've already started that one, hopefully it's going to work. Okay, it's working. And here you can see the Graph Studio user interface, which guides you or which provides you with the steps of a typical graph workflow, starting with creating a model, creating the graph from that model, which creates also the respective tables in your graph user schema. And if that is done, and if the graph is loaded into memory, which what I'm going to do right now, then we can use the analytic approach to work with a graph. So I'm going to wait a few seconds to have the graph loaded into memory in order to use Graph Studio here. What you can see here is a environment that is created, which means that there is a virtual machines created in the background that has all the necessary tools and installed and started in order to work with property graph and graph server. So this takes some time. If you have a bigger graph that probably requires a a lot more memory, you can use that environment setting here to create a graph that is bigger than the default, and the default is actually here 14 gigabytes. So if you know that your graph loaded into memory will be higher than, or will require more than 14 gigabytes, then you should set the environment here before. Okay, so the environment is created, and now the graph is loaded into memory. That is done. Okay, so let's get back to that part here. So what we can see here now is that the graph is loaded into memory, and now we are able to work with the graph. And here I've prepared a notebook doing some of the analysis. Sorry, this wasn't, was it the right one? Yeah.
I think that looks good.
Yeah, it's the right one. Actually, I've enhanced a little bit what you can see here in the workshop, which is this part. Let me go further down. So creating the graph is described in this workshop, in this lab here. So this we have done already, and querying and analyzing the graph is part of that lab. And here you can see step by step what you can do and how the notebook looks like, and what you can exactly do step by step in terms of analyzing the graph. So let me get back to my notebook. So here we can actually use a Java client, which is mentioned here. This is one of the interpreters for this embedded notebook, that we can use Java for working with a graph. We can also use Python, which is kind of can easily be seen here. So if you want to add a new paragraph in that notebook, you can directly choose here from the interpreters, and then you have you just write your code here.
Maybe it's actually worth asking who has been using notebooks in the past. I mean, if now that you're in the Zoom session here, you have this button at the bottom, reactions, and if you maybe just give us a thumbs up if you've been using notebooks in the past, maybe that's something you could do. Then we have a feeling for who has been using notebooks and knows how these things function. So can you click on the reactions button and then give us a thumbs up? Okay, I can see one thumbs up here. That's not too many yet. So everybody wake up, kindly wake up and click on the reactions button on your screen and give us a thumbs up if you've been using notebooks in the past. Okay, that doesn't seem to be too many, so it may be worth briefly explaining what a notebook is, Karin.
Actually, notebook is an environment to run. Yeah, it's mostly used by data scientists. And a notebook is able to run step-by-step code in different programming languages. And here we do support Java as programming language. We do support Python. We do support the property graph query language directly. And it also typically provides an interpreter to also enhance your notebook with text fragments that explain what you're doing in a specific paragraph. So when you look here, there is a markdown interpreter, and there is a markdown syntax to write, in this case, the explanation what you're going to do right here in this notebook. And then per paragraph, you can run the code that is embedded in that paragraph and that refers to the interpreter and then can do it in the different programming languages or for the interpreter like Markdown and visualize the result there. What you typically have as well as part of this notebook is that you have these kind of this kind of tooling here, which either lets you set some settings specific to a Markdown paragraph. So you can't do that much with a Markdown paragraph. But here, with the result of that query, you can see here that you have an icon where you can switch between the raw result set given back as raw text, or having a tabular presentation of the resulting of what's resulting as output from that piece of code. And this is something we heavily make use of in the paragraphs that are following here, since we want to use a visual representation of the result set of a query or of a graph analysis in order to see better see than with a tabular representation where the clusters are, where important persons are, or where important accounts are, or these are used or are features of that paragraph embedded in notebooks. Okay, so here we again have a paragraph that is written in Java. So we have some Java code that just looks at the session we have just started before, and gives some information back about the session. So here we see that we have loaded a graph called a bank graph, and this bank graph has 1,000 edges, 1,000 vertices. Vertices is a similar term for also nodes in a graph, and the edges, which are the relationships between the nodes. We can use also Python. I have this is just text here, so I haven't made much use of Python here, but we could include also Python code directly. And what I'm going to show is right now using the property graph query language as part of the notebook. Here's an explanation of how a property graph query language statement looks like, and it's very similar to what you know from SQL. So select, from, where, order by, limit, those kind of clauses are familiar to you. What's probably new is this match clause on a graph. And this is specific for property graphs. Match gives you is a clause to define the topology of the graph you want to look at and the pieces of the graph, and on specifies the graph. So especially if you have more than one graph loaded into memory, then it's necessary to specify which of the graphs you want to query. And this is what we are going to do here. So taking also from the lab, we have a select statement, select star from match, limited to a result set of 100. And what we see here, let me just switch back to the tabular node. Since we haven't specified which properties or attributes of the nodes and edges we want to show, it just simply takes the vertex information and the edge information and displays those here. But the better visualization is this one. So here you can see the nodes and vertices, and I've also used the settings here to specifically visualize the counts, and then show in a certain way the transfers between those accounts and label those transfers with the amount that has been transferred. Is this understandable as a simple pattern of querying a graph? So maybe I should say a little bit about that. The match clause here. So what you can see here in parentheses is a node, or also called vertex, that is related via an edge, here labeled as T, with another node. So meaning S and D are types of nodes, but are different from each other. And they are related via an edge of any type that is stored as an edge in the graph.
And you can even see it as a directed edge because it's got this little arrow,
yeah,
right?
Yeah, exactly.
Because money flows from one account to the other, and it's directional. While I mean, there may be some relationships which are not directional, but money flows typically are.
Yeah. And as I mentioned before, you have all kind of features as part of the paragraph and the notebook. So here we have specifically for working with graphs, we can highlight how transfers should look like, hence edges that are labeled as transfer, or nodes that are labeled as edge. We can also choose how we want to visualize the graph. So there could be a concentric visualization of that graph, and it looks a little bit different. So something like you've seen before for the PaySafe graph, which has this type of circular or concentric representation of the graph. And now we want to find out potential fraud patterns. Here also labeled as circular payments, or a chain of payments that start and end in the same account. And for that, we can use built-in features of that property graph querying, which is an in degree and an out degree method. And we can use something in the match clause that is this kind of pattern here. So we have an edge that is a transfer, and we want to specifically look at a minimum of 5 transfers or hops between the accounts. And this is
sorry, you're correct. This is exactly 5, so it's not a minimum of 5.
Yeah, I'm sorry. This is exactly 5, and here we have minimum of 2 and maximum of 5 hops. This type of representation is up to 5 hops, and here a minimum of 2 and open up to n hops. So, and this gives you probably also an idea why this is so useful when compared with a relational database, when having these kind of circular payments looked at, and we want to find out the payments over a large number of hops, then we would end up in self-joins of the same tables for that number of hops, and then doing a query with a relational model and SQL, it's just, it costs a lot and probably won't give you the result back, in, at least not in the time you are looking for. Okay, so here we have we make use of the in degree and out degree feature, and then summarize the number of transactions that come into an account and those that go out from an account, and then just have this tabular representation. here is the this fraudulent pattern where we have a transfer going by different hops, or here exactly 5 hops from one account and ending up in the same account. And we are specifically looking at this account and can that represent here as a graph. We can even extend that one if you want to look a little bit more in details. Then you can extend that graph here, starting from account number 934 and extending those with the next two neighbors and the relationship between the next two neighbors. And so this is how you can visually work with a graph as part of the notebook and the graph visualization features for this notebook. Here you have another approach how to query or to do circular payments. So we have this starting node, we have a transfer of 4 hops resulting in a different node, and from there we have another transfer going back to the first account, which is basically the same kind of query we have seen here before. So which is similar to this one. But we have we can use this node here and see whether this belongs to a certain person and figure out whether there is a relationship here that can be explicitly queried as well. So these are certain variations of using property graph query language, and the pattern here, or the topology for the graph, to query the graph, to visualize the graph. You can also use bind variables, which is something I've done here. So this is everything you can do with this visual interface. And then when it comes to graph algorithms, I'm going to use the Java API to run a specific algorithm here. I'm using the PageRank algorithm on that bank graph. And when running that algorithm, then there's a new attribute created on the vertices or nodes that is called PageRank. Here you have the result of the properties named PageRank, and then you can use that value and include it in your analysis. So I'm doing here kind of same analysis as before, but the visualization here is based on the PageRank. So what you can see here is the higher the PageRank, the higher the diameter of the node is. So I can use the PageRank value and put it as a condition in the visualization. And actually I'm restricting here on the I'm assigning the color red and a bigger size of the bigger diameter for the nodes for all the PageRank values, or for nodes that have a PageRank value higher than a certain value. So this is something you can do visually, but you can also use the PageRank to run the analysis. So here's again a tabular analysis, putting the top 10 accounts, my PageRank in a list. Then you can compare it with other analysis. So this is actually what you can do, and very easily run and test using that notebook approach. Maybe
now, I think we haven't been talking too much about the algorithms at this stage, so I'm not sure, is everybody familiar with PageRank as an algorithm, or does anybody have questions about the algorithms?
Hans, do you want to say a few words at least about PageRank?
Yeah, maybe I can do that. I mean, as Karin was mentioning in the beginning, we have different classes of graph algorithms, which you may or may not have come across in the context of graph theory, right? And PageRank is among the, as it indicates, among the ranking algorithms, which is designed to give you a measure of importance, right? If you have a social network, let's say, and you're looking for customers in that social network who are particularly important, then of course the first question is what is important, right? What would be an important customer? Now, an important customer can be someone who's connected to many other customers. Sure, that would be one simple measure. That would be what Karin was showing with the in degree and out degree. It's just counting the number of connections, right? That's simple, but that's not necessarily accurate. Oh, it's not necessarily the measure of importance which you're looking at. Another measure of importance could be to take into account whether somebody is connected to someone else who is very important. So maybe there's one person who is connected only to one other person, but if that other person is connected to thousands of customers, the first customer would actually be relatively important, right? If you are connected to, I don't know, the President of the United States, well, you are probably important, even if you only have one connection. So this kind of measure of importance, depending on the importance of surrounding nodes, that is actually what PageRank tries to take into account. PageRank was actually originally developed by Larry Page, so that's why it's called PageRank. It's got nothing to do with the web pages which it was designed for, and it doesn't only look at the number of connections, so the number of URLs pointing to a given page, but it also looks at how important, sort of recursively looks at how important that page is. And that is an interesting measure, for example, for prominence. Google used it to rank the search results initially, and you can use it to rank the importance of customers, for example. There may be other measures of importance in social networks or in any kind of graph, for example, looking at what is known as betweenness centrality, which particularly highlights those vertices in the graph which are sitting between communities, right? So think about project teams, right? If you represent your project teams as graphs, people collaborating on one and the same project are in the same part of the graph, they're all interconnected. If there is one person who is the only person working on two projects, so essentially being the link between these two projects, then that person is probably very important, because if that person leaves the company, you have a problem with the communication between the two project teams. So between the centrality can be another measure of importance. And so all of these algorithms are designed to highlight certain features of the graph, certain characteristics of the graph, certain topology of a graph, and you can have all kinds of other algorithms. But just to give you an idea of what is doable with graph algorithms, I hope that helped to clarify things a little bit.
Any questions on that?
And as we're a relatively small group, feel free to ask questions, right? It's,
yeah, sure.
yes, there's one.
You don't know to be certain.
So you can write it in the chat, or you can unmute yourself and just ask the question.
Yeah, whatever you prefer.
Okay, perfect.
So I've seen that, Hans, I've seen that you have shared the specification of this PGQL language. Yes. All the what you have sent in the chat will be put in the description of the recording. And okay. Yeah, for those who join later, I remind that the session is recorded and it will be available for all the registrants.
Okay.
Excellent. Thanks for taking care of that, because that is typically what is the problem. Otherwise, if we put things into chat and somebody goes and watches the recording, that information is lost. So thanks for putting that into the description.
Okay. So maybe for the sake of time, I'm just briefly going to talk about another use case. So I've been looking at several use cases how to that are probably more familiar to you. One approach would be to look at the sample schemas that come along with the Oracle database and to visualize as a graph or to model the HR schema or the SH schema as a graph, and which you can easily do as well. So this is what we where we said that you can take your relational model data and easily apply a graph model on top of that. And this would be, some, for example, one outcome to display the hierarchies of that human resource employees data, where you have Larry King at the top and then all those employees underneath. So this would be one example. But what I wanted to show you right now actually is something I've tried to prepare as in terms of analyzing the privileges of database users. And what I've actually done here is, maybe I can share with you some scripting. So actually, when you look at the database, you have typically several users, and those users have privileges and roles assigned. And when I want to figure out what kind of privileges which users have directly or indirectly been granted with, I could also use this graph approach to do the analysis and visualize the results. And in order to adapt it for the autonomous database, which has some restrictions in terms of user privileges, I've actually used the admin account to assign some privileges to the graph user I'm using for doing the analysis. And then before doing the analysis with that user, I'm creating views of the database privileges metadata, which you can typically query by these types of views that are provided as part of every Oracle database. So you have a view called DBA underscore this underscore privs. You have another view called where we have it, database DBA underscore roles, DBA underscore role underscore privs. So all these dependencies between users and roles and privileges are actually stored in these metadata of the Oracle database. And there are some specific as well. There are roles, there is a role called public, and this is something that is not explicitly where we implicitly assign privileges to all users in the Oracle database. So this is something we specifically need to handle here by including those types of roles as well. So I've created a bunch of views regarding these type of metadata, and then I've granted privileges for the graph user to actually select from these views, which I've done then using this graph user. And on top of these views in the user graph user, I've actually created the graph model. And here you can see as part of the property graph query language, there's also a DDL interface which can lets you create the graph model itself. And what you see here is one version of creating the graph model. Maybe I can go back briefly to my presentation to explain a little bit of the background. So what you can see here is different ways how you can create your graph. I'm sorry. No. So this is something here. You can specifically assign edges that are labeled has role or has privilege, or you can just say a role is connected, a user is connected to a role via this edge that is labeled has. The role is connected to a privilege also via an edge that is labeled has. So there are typically more than one graph model. So it's always the best when choosing the right graph model or the best fit for a graph model to think from the end, what kind of queries I want to answer, and then applying or developing the graph model on top of those questions. And I've actually implemented both models here with the specifics, the distinction between roles and privileges, and also one that doesn't distinct between those. And I've created actually, here you can see the metadata model for the graph, the first version of the graph and the second version of the graph. And then you can create your notebooks on top of that. And this is something I've put in here. So let me start just briefly to look at it. So again, we're going to query some general information about the session itself, then whether the graph is loaded into memory. I haven't used loaded in. This is the result from something I've done, checked this morning. Then it was loaded into memory, actually 2 graphs. And then I've done everything twice, for the first version of the graph and for the second version of the graph, and the results might be different, but not for all of them, of course, depending on the kind of query I'm asking. I'm getting similar or differences in the results. And you can see again here the property graph query language used for analyzing the graph, either representing the result as in a tabular form, or here also representing the result in a graphical way. So, and maybe this is something here, I'm looking for roles that are indirectly granted to a specific user via a chain of roles. So similar to what we are doing with chain of transactions. And here is the syntax we've seen before for the transactions as well. So we have a user connected to a role via this edge has a role, and there has to be at least one edge in between this user and the role, or it can be more. This plus is similar to what we have seen the other kind of edges where we have specifically said 2 to 5. Here we say at least 1 or more. A star would be 0 or more, so similar to what we know from regular expressions. And then the result here is shown as a graph. So this is actually the same kind of analysis and visualizing the graph and having the result there, and using also the graph algorithms and taking into account what we have computed here. So again, PageRank I've used here to calculate the importance of the users and roles and privilege nodes to determine how the importance is. And here you see a tabular result of doing the analysis actually on top of the page rank that has been determined before. Okay, so it's very easy to take existing relational models and try to figure out or to get new views on your data, to analyze your data in a new way when using these type of query language, and also using the graph algorithms. I hope this is something you can take away from today, at least this. Okay. Then let me get back to the slides. We have skipped a few slides. We can probably briefly go over those. They will be just, sorry, I think I stopped somewhere here. So we have defined a graph model based on our relational tables. We probably have a look at it before to understand it and how data are related, and then also use this information to define on the best graph model. Then we create the graph model, and this is the type of define or the data definition language as part of the property graph language, where we can define the graph, and then we do the analysis based on the property graph query language and the algorithms. So maybe I'm going to skip here, but just let me go briefly over that one. And, we have seen the property graph query language. If you want to see the specifics of that, you can find those here in this open source project, which has been set up by our by Oracle Labs, which is our research department that is working on defining this property graph query language. Hans, do you want to give a brief outlook on what we are going and what we are supporting in terms of standardization of SQL?
Yeah. Okay. So yes, I can briefly comment. Yeah, that's a good point. I can probably comment on that. So as Karin mentioned earlier, in among the query languages for these kinds of property graphs, there are no standards yet. There are a few approaches. Most of them are actually relatively similar. They typically have a match clause like we do in order to specify the pattern you're looking for. But as I said, there are no standards. And what we're currently working on with various other players in the industry is in the working group at ANSI and ISO, which is responsible for the standardization of the SQL query language, we are proposing, or we're working on, a new extension for property graphs. That extension will be called SQL PGQ for property graph queries, and it'll have a match clause like this. What we are interested in, of course, is to make sure that there is no mismatch between SQL and the property graph query language when it comes to things such as handling of null and the data types and all these kinds of things. So that is an effort which is currently underway, and we are working on a project, but this is a project, right? It's one of the Oracle 23 projects, which is going to provide support for SQL PGQ in the Oracle database in the 23 timeframe. Now, don't take my word for it, right? This is a project. 23 is still, a while in the future, right? There's still risks involved, but this is what we have planned, and you'll see more functionality included in the SQL language in Oracle over time.
Okay, So right now we have property graph query language on top of SQL. And you can either use SQL as part of Graph Studio or with the different clients I've mentioned before. One of the clients is actually SQL, where you just download a plugin for PGQL to run those kind of queries. Okay. So we have seen the PGQL syntax.
So I will start again, and I will link the movies. Okay, the participants are joining. Sorry again.
Okay.
Okay,
That was
probably I've talked too much, so
No. Sorry, it was not
I'm sorry.
intended. I was trying to switch to another device.
Ah, okay. I thought it was my fault because I mentioned already to Hans, I have a Monday laptop, so with kind of flaws.
Okay, so sorry again, if you can continue the presentation, please.
Okay, we've got 3/4 of the people back online. That's good. I'm actually quite impressed.
Okay, so can you give me presenter rights so I can share my screen, Ciprian? So I can't share my screen right now.
Okay, you're the host now, Karin.
Okay. So we've talked about the syntax of PGQL and DApps. So let me just go over that. And also the examples. There are many more examples and clauses that can be used here. Shortest path, top three, shortest path queries. Then aggregating nodes, all those kind of things. I haven't talked about those in details, but you can do a lot of things using PGQL. And as Hans already also mentioned and talked about the inbuilt graph algorithms. So we've talked about the PageRank, and he explained it, what it means. There are many more algorithms in the different sections. So detecting communities, there we have algorithms. I talked about the Louvain algorithm that is used by PITS. Doing some analysis on the topology of the graph, like counting triangles, or the reachability. Yeah. So there are plenty of algorithms you can use as well. And you can also feed machine learning models with the results of running the algorithms. So you can easily combine graph algorithms and the results, and then go ahead and apply machine learning models. Oops.
Just 1 second.
Okay.
I need to make you co-host because I need to. Sorry.
Okay, don't worry. So I'm glad that it's not my fault.
Well, today I need to apologize a lot. Sorry.
No, don't worry. Okay, perfect. So, okay, so this is about PageRank, the importance of nodes. We've talked in depth about the algorithms and how to run those, what kind of programming interfaces we provide for this. So if you are a Java or Python developer, you can get started with those. For example, the Fismon example, this is an application developed in Java. So they use the Java API to do everything with the graph. And this is we've seen before, the two demo parts. Yeah, just let me sum up. When looking back back at how we have developed things in terms of being able to creating a graph, analyzing a graph. We have used Graph Studio to demonstrate this. We've created a graph model. We populate the data structures in memory to run the queries efficiently, and also execute the algorithms and show the results. So this is, you have seen before. Maybe one thing I can mention, I've touched on briefly at the beginning. So we, when I said we support two types of graphs via the Oracle database, and one is the RDF, or so-called resource description framework knowledge graphs. We do support this in the database, and we will make it available with Graph Studio. And this is something that is planned soon to be delivered. Don't make me accountable for when soon is. But there you have a similar approach. You have a query language that is called Sparker, and you can work with Sparker to query a knowledge graph. And knowledge graphs have heavy support from the W3C organization, so they're much more standardized than property graphs, and this is something we've been working also over the years with ours to develop and support those standards that are known from knowledge graphs or RDF graphs. Okay, so when looking at graphs or looking differently on your existing data or new data, think about graphs. If you have a schema-less approach and you want to analyze your data, then graphs could be a very valid approach. Yeah, we would like to hear if you have any ideas or any projects, or whether you have already looked into graph databases and want to do something, then we are happy to support you with it. I've shared our email addresses in the title slide, so it's very easy. First name dot last name @oracle.com. So feel free to reach out to either Hans or me or both of us. We would be happy to do more projects with you to learn about your specific use cases. So just feel free.
Yeah, and if you have a concrete project which you've already implemented using our graph technologies, there may even be an opportunity to present on that. Sure, sure. Because we have the analytics and data Oracle user community, the global analytics community, which was originally part of the RoUG. They run a TechCast Days event again in May, and we'll have half a day worth of graph technologies again, like we had last October, and therefore and the call for papers is essentially open, so feel free to reach out to us if you have anything which you could present. We had a couple of very nice short demos also, even if it was just short talks, like Kim Berg-Hansen, whom you may or may not know as one of the Oracle aces. He's been talking about using Oracle graph technologies for the purpose of analyzing, or for the game of 6 Degrees of Kevin Bacon. Not sure if you are aware of that, but it's a game where you're looking at actors and actors who have been acting together on one and the same movie, and he showed how he could do the analysis in SQL, in PL SQL, and in PGQL. And that was a like 10-15 minutes demo, for example. If you've got something like this, if you have a nice data set, which would be interesting to look into using graph technologies, which you would like to talk about, you can either do that, I'm sure, as part of the ongoing RoOUG TechCast, TechSession series, which we're talking about today, or you can do that to an international audience if you prefer to do that in English. Sorry, Karin, I kind of interrupted you. Apologies for that.
That's fine. That's fine. So whenever you need to analyze relationships, where relationships are the crucial part of it, just think about graphs and then let us know. We are happy to support you with any kind of requirements you have there. So, any further questions, remarks, or whatsoever? I have probably talked too much today.
I have some. I have
Sure.
some regarding this notebooks and the Zeppelin. How are they integrated with the graph server? How are the rendering of the graphs, or let's try to see it the other way. Okay, we as a user, as a let's say trying to be a user of Oracle Spatial, I will follow this notebook and I will follow the tutorial. But afterwards, when I want to go, let's say, and try it on a technology stack, what are the steps?
Mm-hmm. So I mentioned the download page for the Oracle Graph Server and client tools. And there you can download the plugin for Jupyter Notebook. So in order to be able to run what you have shown you before for the graph analytics part. So let me just check.
So was the question primarily about the infrastructure you would need to set up if you want to run this on premise? Or, I mean, I hope it's become clear that Karin was showing things for demo purposes using Graph Studio because it's nice, it's all integrated, it's all up and running. We take care of all the management, so you don't need to install anything. The notebook is an integral part in that, so there's nothing for you to do, nothing to install, nothing to configure. So that would be sort of the autonomous database. If you want to run this in your own environment, as Karin was saying at the beginning, you have the Graph Server and Client Kit you can download and install, or if you want to make it if you want to do this on the Oracle Cloud but not using the autonomous database, there is a marketplace image which you can just install and spin up, and then that's all done. Or final version, if you have a notebook, or if you have Zeppelin, for example, already, what Karin is just showing you is the Oracle Graph client for Zeppelin. All you need to install is the interpreter, which you need for Zeppelin, and then you can connect to the infrastructure if you have it running somewhere. So that would be the piece. For Jupyter, it's even more simple because all you need is the PyPGX client library, so the Python support, the Python API essentially, which we offer, and then within Jupyter you have that functionality straight away.
Mm-hmm.
Does that answer the question? Or did I misunderstand?
Yeah, I think yes. I needed to see. Okay, after I let's say tested on the notebook, what is the next step for let's say a bigger project or something like this?
I see. Yeah, I mean, maybe one hint could be Ryota's medium.com blog posts on medium.com/Oracle devs. I can send you the project. That's also got an example of how to set up the entire environment using Docker and so on. I can share that on chat in just a minute. I just need to find that.
I just found it.
Oh, you got it. Okay, that was quick. Okay, so, here we go. Yes.
Yeah, and this is actually an example here where he is connected to the Oracle database using SQL CL with the PGQL plugin, and you switch from SQL to PGQL by using this statement here, PGQL auto on. You can also see, say, PGQL auto on translate, and then you can see exactly what's happening in the database, how we query data when querying the graph directly in the Oracle database and not using the memory loaded graph.
And the next question is actually related to that. It's from Julian asking, what about Oracle Graph Client for PL SQL? Can you tell us some details about this, Karin? Do you want to say a few words, or should I do that?
Just go ahead.
Okay, all right. So the PL SQL part is actually functionality which we provide within the database for graph analytics, which, for example, Oracle Analytics Cloud can make use of. That is somewhat limited. It is essentially the support for 5 algorithms only. And obviously, as it's all based on PL SQL, it does not have the in-memory graph analytics engine with its high performance and so forth. So it is not quite as scalable. But if you have a small project and if you want to make use of the core functionality, that may already be sufficient. And as I said, if you have Oracle Analytics Cloud, that'll be what you would be using, for example. But it is only a tiny piece of the functionality, and it doesn't scale as well because it's not the same engine yet. Okay, I hope I answered that one.
Okay.
Anybody
so
else?
Those information you find as part of the property graph query language documentation as part of the Oracle database documentation.
Yeah, it's good you mentioned that because people have been confused about where to find the documentation and so forth. So it's good you're showing this.
Okay, and as I mentioned before, there is a series of blog posts from Ryota on medium.com, and he is explaining also the RDF part, but here he has a series of blog posts regarding this, analyzing bank transactions using the same approach, but doing it on his own environment. Okay. Any other questions? So it's 7 o'clock, or even after 7 o'clock.
Ah, it's 7 o'clock already in Bucharest. Yes, of course.
So
I forget.
maybe
Time to have dinner.
yeah.
No problem.
Okay. So
Thank you. So once again, I need to apologize for the interruption.
No
but
worries.
there is something. I'm now starting a new other class, and I'm with some children teaching some martial arts. But that's why I needed to.
That's why you needed to switch to another device.
To another device.
Oh,
and
okay.
yeah.
Now
So apologies for my part. Thank you all for attending this one. It was very interesting. I will record and put it online, and I will share with everyone. So thanks again. If you have anything else to say, please go again. Go ahead.
No, thank you to everybody for participating. That was good. I really enjoyed that. So hope to be in touch. And maybe we'll see each other at the live conference at some stage again.
Let's hope so. Thank you so much, Karin. Thank you so much, Hans.
You're welcome.
It was an interesting introduction lesson, and I hope that people will try it. And
yeah, just try it. It's
yes,
always the best way to get started. Yeah.
Interesting use case. So yeah, just find the frauds in banks. Go ahead. Find where the money are going.
Yeah, indeed.
Thank you, and have a good evening, everyone. See you somewhere, sometime.
You too as well. Stay safe.
Yes,
and,
thanks a lot.
You too, stay safe.
Yeah. And talk to you soon, hopefully.
Hopefully.
Hopefully. All right.
Yes.
Bye, everyone.
Bye.
Bye.
Thanks
Thank
a lot.
Bye, and have fun, Ciprian.
Thank you. Bye for now.
Bye.
Bye-bye.